This video will be about dilations. Now, we're going to go quickly through some of our definitions because we covered them at the beginning of class today. And so we want to spend some more time on actually working on some problems here. So a dilation is a transformation with proportional size and congruent angles. And if you recall, that deals with similarity, which we'll talk about later. The scale factor multiplies or divides in a dilation to obtain the image. Now we can't emphasize enough, it multiplies or divides. It's not going to do something else, it will multiply or divide. It cannot add or subtract. The scale factor multiplies or divides. Okay? And the formula for K is image over pre-image. Now, I do want us to be able to observe based on K what's going to happen to our image. Okay, so you've got a few questions to answer here on these three for review. So, for K, if K is less than 1 but bigger than 0, we're multiplying. So multiply by something smaller than 1, so our image is going to get smaller. Okay? If K equals 1, that means we multiply by 1, and so our image gets the same size. Okay? Now if K is bigger than 1, that means we're multiplying by 2 or 3 or 4 or some other number, but we're multiplying, so the image will be getting larger. Okay? So we have a reduction and an enlargement. All right, so let's go ahead and check a couple things of how to find scale factor and also how to do a dilation. Okay, so let's go ahead and look at scale factor. So we have a triangle here, and here's our pre-image. Here's our image. Let's say we've got 3, 7, and 10. Okay, I'm just going to pick lengths here. And now we've got 12, 28, and 40. Okay, now, in order to check this, we have to use our scale factor formula. Our scale factor formula is K equals image over pre-image. Okay, so K equals, we can pick any of these three sides, 40 over 10. They have to correspond to each other. Okay, now that equals 4 for our scale factor. Now we have to make sure that it works for all of ours. So K equals 12 over 3, that's 4, and K equals 28 over 7, that's 4. Okay, so we're good to go. We know the scale factor for these two triangles is going to be 4. So let's go ahead and perform a dilation. Okay, so on your notes you saw what dilation is going to look like, but we have to think what we're going to try to carry one out. And it's going to have a center of dilation that is not the origin. Okay, because the origin is kind of straightforward. We're going to have one that's not the origin. So here's our triangle, and we're going to dilate about the point 1, 0. Okay, so there's C for center of dilation. Okay, so we're going to dilate about 1, 0 by 3. Okay, so what we're going to do is we're going to see, okay, how far away are we from our center of dilation? So this point right here is 1 away. So we're going to multiply, because scale factor is a multiplier, multiply by 3. So 1 is the distance times 3. So it should be 1, 2, 3. Okay, notice how we did not add 3. Notice how we multiplied the distance by 3 to the new distance. Okay, now see how these are all on the same line. Those should all be on the same line. Let's say look at the point down here. We went 1 to the right and 1, 2, 3 down. Okay, so we multiply by 3. We went 1 to the right, we should go 3 to the right. 1, 2, 3. And we went 3 down, so we should go 9 down. 1, 2, 3, 4, 5, 6. Further down, 7, 8, 9. Okay. And then our point over here is 2 away and 1 down. So it should be 6 away, 1, 2, 3, 4, 5, 6, and 3 down, 1, 2, 3. Now notice about the sides and the pre-image and the image. They all are proportional. The angles are the same. Okay? Now, as we said before, we said this dashed line here, through center dilation, it's going to go through these points too. Okay? That's a good way to find your center of dilation because it's going to connect on those dotted lines. Okay? So you've got some questions to solve on your own.